Okay, now let's talk about how one particular model gets evaluated repeatedly using different samples. So one approach in ensemble, remember we talked about this previously, one approach for ensemble is have many different models and then combine all of them. The second approach is to just take one model and apply it again and again with different tuning parameters and different samples from the data set. And that has an effect of reducing the variance of predictions also. So there are a couple of popular techniques. One is called bagging and then one is called boosting. So let's talk about bagging first. Bagging is short for bootstrap aggregating. So you get the B from bootstrap, AGG from aggregating, so you get bagging. Now, bootstrap sampling is a particular way of sampling, and that is you generate samples, multiple samples with replacement. So you take, suppose you want, you have 100,000 records, and we want to take 10,000 observations as a sample from it. Okay, so you take one sample at random, put it back, and then take another one, and then put that back in to the pool. So what this means is a given observation may get selected multiple times. Okay. Now, of course, you do that in a stratified setting, like if you have class 0 and class 1, you will make sure that the proportion is maintained. So when you do that, you will be able to take multiple samples from the given data set. So for example, if you have 10,000 observations and you want to take 2,000 at a time and you want to do it 10 times. So you actually end up having what 2,000 times 10, 20,000 instead of 10,000. You will have 20,000 observations, some of them repeated, of course. So that is called bootstrapping. So you select multiple samples from the existing data, and when you do sampling, you do sampling with replacement, and then you run the algorithm of each sample and combine the results. So that's aggregating. So this approach is called bagging. So here it's an example, small. Suppose if you have only 6 cases. Okay. So first sample, so you take that one time, this one 2 times, this one 2 times, this one 1 time. So you have now here you're sampling 6 observations from 6 observations. So here is a first sample. The second sample, so you get in the first sample, these 2 observations do not get selected because of randomness, and here these are the observations that get selected, and here again. Okay, so bagging improves stability and helps avoid overfitting. And in SAS, as we will see in a different video, it's done through 2 nodes, start groups and end groups. Okay, in start groups, you will select the type. So you want bagging or bootstrap, bagging or boosting, and then you have the model, and you can have all kinds of transformations and things like that, and then the final model. So you can have multiple nodes in between, and then you will have the end group. The end group, all it does is it throws the computation stream back to the start group, and then the whole thing gets started again. And here the end group aggregates the results of each iteration. So that's bagging. Now boosting is slightly different. The goal of boosting is to improve the areas in data where we are making mistakes, right? So you take a sample and you do the analysis, and you check with the check the results, and then see that you have misclassified. The model is misclassified in the training data. Now you're not looking at the validation data. The training data, you misclassified some observations. So now you go back and you sample more of the misclassified observations. You give the misclassified observations more of a chance to get selected. So the cases where we are making classification errors have higher likelihood of getting selected into the next sample. So in boosting, you're again, like in bagging, you're repeating the samples, but instead of simply allowing sampling with replacement, in boosting you're channeling, or you're making the misclassified observations more of having more of a chance to get selected in the sample. So this is the adaptive resampling and combining method. So fit a model to the data, okay, generate a sample over sample misclassified cases, okay, and fit the model to the new sample, and then repeat 2 and 3 multiple times until you get satisfactory results. So here is an example. Suppose the same 6 cases. So first time you take all of them and you run the model, right? So now you have 2 misclassified observations. Now what you do is you make the, so here let's assume that this is the probability of a particular observation getting selected in the sample. So you make these 2 samples probability of getting selected as 1.5, and then the additional 1 likelihood is now distributed, taken away from these 4. Now run the model. Now you keep track of how many times a particular observation gets misclassified. Suppose in the second iteration, this one is no longer misclassified, so the cumulative misclassification is only 1. First time is misclassified, second time correctly classified, so it's 1. Okay, here no problem. Here, suppose the second time also it gets misclassified, so it gets a misclassification ranking of 2. And here, first time it was okay, but the second time it got misclassified, so it gets a 1. So now again you adjust the probabilities. Okay, so these are the adjusted probabilities, and then do the sampling again and keep repeating in this fashion. So M is the running count of how many times the case is misclassified. Again, in SAS, you will do the selection here in the start groups. You will select boosting or bagging, whichever the case may be, to run your analysis. Now, the advantages and disadvantages of these boosting and bagging methodologies: more precise predictions. It improves stability. Stability meaning the variance of the errors, it will be small. It helps avoid overfitting. Of course, the disadvantage being it requires more resources, because you're going to keep running the analysis again and again and again. It takes time. And ensemble models are not interpretable because you're combining many different results, so you will not be able to interpret, like in the regression analysis case, you interpret the slope coefficients, you won't be able to do any of that.